read a story of St. Nicholas and Christmas and the biochemistry of Christmas. Are you excited about it, children? Fantastic. I'm going to turn my camera off because this outfit is so blooming hot. But you can imagine me sitting here with Christmas, being ready for Christmas, with some mulled wine and German Christmas stollen. And guess what I'm going to have tonight? So, can you see my screen? God, I've got all the hairs now in my mouth. This is horrible. Poor Santa. Oh, and I'm terribly sorry. There are no doggies at the moment, but maybe I can get them in a little bit later so that people can have a look at them. So, our last lecture. How is that? How do you feel? Oh, the Lebkuchen. That's a very good question. I'm terribly sorry. No Lebkuchen are left because they don't live very long in our house. So, anyway, let's tell the story about Santa, the true story, and his helpers, because you are all familiar, I guess, with the story of St. Nicholas, as it was so lovely described by Clement Clark Moore in this poem, A Visit from St. Nicholas, which was written 1823. And unfortunately, things are not exactly as they are sold to you. There are lots of sort of twists in the Santa plot. Let's start first with one of the helpers. And of course, you know that Santa is supported by reindeers. And of course, how would I forget Rudolph? And absolutely, you need to make notes because this is the most important lecture of your life. Absolutely. Of course, no animal lives on the North Pole because North Pole, that's just water, which is frozen. So there are no animals there. But if you think about Rudolph, what is typical of Rudolph? What do we know about Rudolph? Yes, the nose, the red nose, absolutely. What else? And that gives you a clue to why I have issues with Rudolph. He gets bullied? No, that's all right. What else? Look at that. What has he got? Yes, he is male and he has antlers. And now all the alarm bells should be ringing. Why? You're absolutely right. If it is a male reindeer, like Rudolph pretends to be, then they would lose their antlers in late November mid-December. However, St. Nicholas is visiting on Christmas Day in the English and American culture. For example, in Germany, St. Nicholas, when does St. Nicholas visit? In Germany. Nope, it's not the 14th. It's the 6th. Exactly, it's the 6th of December. So in Germany, Rudolph could actually be a male reindeer. But if you look at the story from an anglicistic point of view, Rudolph should not have antlers because only females keep their antlers until about springtime. So Rudolph is an imposter. It's either Rudolphina or, well, God knows what he is. Eastern European or the Greek Orthodox would be even later. That would be around the 6th of January, if I'm not mistaken. And Rudolph might be gender fluid, I don't know, but nobody told us about that. And of course, they don't have to come out, but Rudolph with antlers, be very careful. Now, also be very, very careful about this guy here. This is Santa. Of course it is Santa. But what is the story actually about Santa? And where does it come from? Have you ever asked yourself? And what is he doing? That's quite interesting because I almost gave it away. Because when you look at all the literature, if you look at all the literature, Santa is a typical character of the North, especially of Northeast. So Scandinavian literature and also in the Russian literature. And I think there is a clue to it because very often people are described with sort of almost a little bit like a Santa outfit as the shamans. These were the connectors of the world as we know it to the magical world, to the other world. And these shamans were basically like doctors, like witch doctors with the northern tribes, especially in Siberia. Now, of course, there is an interesting story about that because when I said they have been described with a similar outfit, I'm actually lying a little bit. There's nowhere a description that Santa is actually wearing a red coat or something like that. But you can imagine these shamans, these doctors, they were traveling doctors. Absolutely right, yeah. Oh, do we get a Christmas song? Oh, no. So they were traveling doctors. They healed people and they had to be tucked up quite warm. So they were warm coats, of course. But where's this red stuff coming from? Why is Santa associated with something red? Why is Santa associated with presents and things like that? And there is an explanation. Whether it is the correct explanation, I don't know. But if you think about it, all fits together. because in the area where Santa, where these shamans were active, there's also a mushroom. You probably have seen this mushroom. Do you know actually what this mushroom is called?
Deathcap.
Nope, it's not a deathcap.
Oh.
It's not, well,
Red mushroom.
It's called fly. Where can I write this? Fly agaric. That's the English version. It's the fly agaric mushroom. And now look at this red color of this mushroom with these white dots. And you can immediately see the connection between the red coat of Santa and this mushroom. And if I tell you that this mushroom actually forms a very strong symbiosis with the northern pine trees, it becomes all even more clear. Now, why do I tell you about a mushroom and Santa? Well, actually, it turns out that this mushroom has been used by shamans in order to allow them to connect with the other world. This mushroom contains very potent drugs, hallucinogenic drugs. Don't take this mushroom. It makes you very, very ill if you don't know exactly what you're doing. But this drug in this mushroom makes people, puts people into trance, makes the shamans connect to the other world. And we know that this connection to the other world, which is done by shamans, by witch doctors, and by lots of sort of religious rites or something like that, is a very, very important part of many, many cultures. So, for example, you have the drumming in Japanese culture. You have the spinning dervishes in the Turkish culture. So what these things actually allow you to do is connect, go into trance and have this connection to the other world. So these shamans, which probably were the origin of the Santa belief, used these mushrooms in order to connect to the other world. So what is in these mushrooms? Well, actually, it's quite interesting because the main ingredient of this mushroom is this compound here, ibotenic acid. Now, tell me, what kind of compound is this ibotenic acid? Something that you are familiar with. Yeah, it's probably an alkaloid derived. Yeah. No, it's not meth. It is aromatic, yes, indeed. It is an amino acid, absolutely, because you've got the amino group and you've got an carboxyl group. So this is an amino acid. It's just not one of these amino acids that we use in the genetic code in proteins, but it is classified as an amino acid. Absolutely right. Totally correct. And this ibotenic acid actually is one of the key ingredients of this fly agaric mushroom. It is an amino acid. Now, it is this, and also this ibotenic acid has a quite strong hallucinogenic activity. However, it makes you sick. You throw up when you take a reasonable dosage of this ibotenic acid. You will be sick. So that's no good. However, the shamans, over a long time of drug abuse, obviously they learned how to deal with it, and they developed some tolerance. Why does it make you sick? Is just, you know, it messes with your digestive system, and also it's not very nice. However, there are two tricks actually how you can convert this ibotenic acid, this thing, into the still hallucinogenic compound muscimol. So here, this is this muscimol. It is still quite hallucinogenic, so you get the same effect, but you are no longer getting this sickness, this nausea effect. And there are two ways of dealing with it, or how you get this muscimol out of this ibotenic acid. Do you actually see the chemical reaction that happens to convert ibotenic acid into muscimol? What is happening here? What chemical reaction? What do you think? What's happening? It's not a deamination, no decondensation or condensation, dehydration, no loss of water, no. Let me show you what's happening. You lose this compound here. What is this? That's science, absolutely. No, it's not hydrolysis. What is this compound? It has one carbon and two oxygens, right? So one carbon and two oxygens. This is a decarboxylation. Absolutely right, Camilla. Decarboxylation. A decarboxylation reaction that happens, and it's quite easy because it's almost an irreversible process, because the carbon dioxide then disappears into the air. We don't have to worry about that. So it's almost an irreversible reaction, and this leaves then the muscimol. So how do we get this ibotenic acid to decarboxylate and, in a way, detoxify? As I said, there are two ways. One way is, well, let me put it this way. Humans are not the only ones that like these mushrooms. Guess who else eats these mushrooms?
Reindeers.
Yes, reindeers. Reindeers eat these mushrooms. Absolutely. So, for example, Rudolph would eat the reindeers. How do they find the mushrooms? Here's another interesting fact. Because reindeers actually are the only mammals that can see ultraviolet light. And in the Arctic winter, actually, these mushrooms contain substances that glow in the dark, in sort of that fluoresce in the ultraviolet range. So reindeers eat these mushrooms, and their metabolism can easily deal with this ibotenic acid. They do get high. Reindeers do get high. But during their metabolism, they cut off the carbon dioxide, they decarboxylate, and they produce the muscimol. And this muscimol is then excreted through the kidney. So the reindeers wee muscimol. So all you need to do is eat yellow snow and actually hope that it came from a reindeer that just had some fly agaric and not your neighbor. And you get high. But obviously it has to be the urine of a reindeer that just had quite a number of these fly agaric mushrooms. So you say, ew. But hey, the lengths that some people go to is absolutely amazing. There's another way how you can actually decarboxylate this this substance. Santa basically made his reindeers eat the mushrooms so Santa could have the wee. But there's actually a better way, perhaps a little bit less gross, because what you can do is to do this decarboxylation is you just gently heat up. So I write it as delta T. You heat up ibotenic acid, or you heat up these mushrooms, and soon they will lose their carbon dioxide and the ibotenic acid is converted into muscimol. Now, think about it. How would you heat up these mushrooms, dried mushrooms? How would you dry them and heat them up gently? And it has to be a process over several days. How would you do that? In the oven. Right. No, that's too hot, because this is a very fragile molecule, and it would just simply be destroyed. Water bath. Yeah. Hot spring. Leave it in the sun. Hey, come on, we are in the Arctic Circle. There is no sun in the winter. Microwave, distillation. Imagine you are a shaman in the year, 1600 something. There's no microwave. How could you actually heat up ibotenic acid from the fly agaric? Put them in a pocket. Would put them on a fire. No, you're not putting them on a fire. You would put them next to a fire, next to a fireplace, in a container that absorbs moisture. Can you think of a container that absorbs moisture? No, much easier. There's no cellophane. A thing that you have at the moment, that you're wearing at the moment. No, it's part of clothes. Socks or stockings. You put stockings with these mushrooms next to the fire with these fly agaric, And the mushrooms are absolutely fine. They are not pea or something like that. You just put the mushrooms in the socks, in stockings, next to the fireplace. Now ask yourself, are we doing that as well? Santa brings the presents in stockings. You don't need to put the reindeer pea in it. You don't want to consume the reindeer wee. You just use the mushrooms. Now, what do these mushrooms actually, how does it work? Now, here is the structure of this muskimol. And here is the structure of a potent neurotransmitter in your brain, gamma aminobutyric acid. And if you overlay these two structures, you will find that they are very, very similar actually. So here's a picture of this overlay. This gamma aminobutyric acid is, as I said, is a neurotransmitter in the brain that affects a lot of the brain cells. And it sort of dampens down these cells. So that is sort of the pharmacological effect of this muskimol, because it mimics this gamma aminobutyric acid. And if you have a reasonably high concentration of muskimol, then you end up with sort of a trance state. But obviously, Santa also occasionally shared the mushrooms, the shrooms, with ordinary people or friends or something like that. It's like people have a cannabis party or something, share a joint or something. And so Santa shared these dried mushrooms with the muskimol with other people. And it was sort of, people get high on that. So what is the consequence? Well, actually, it turned out that these GABAergic nerves, actually, when you inhibit them, they lead to some kind of flight fantasies. So people who take these mushrooms, for once, believe they can they have supernatural powers, which the shaman probably had, but also other people saw them, had these fantasies of, oh wow, the shaman is flying, and oh, it is related to reindeers as well. Oh, look at that. So Santa is a magician, is a witch, and Santa provided people with these drugs. And people then perceived or saw the shamans flying through the night sky. Now, of course, these shamans had a very, very important role. They were sort of the people who traveled around, even in the deepest winter, because they were the flying doctors, in a way, literally the flying doctors with the reindeers. And they were traveling around when people got snowed in, for example. They were the sort of almost the Amazon delivery of the day. How did they actually manage to get to the people and provide them with drugs or with, everyday necessities? Imagine you are in a hut with 5 meters of snow. How would you get any deliveries? Down the chimney, exactly. That's the only thing that you can do. So Santa brought the things down the chimney, dropped it down the chimney, all the goods. That was the delivery. And Santa indeed is a high shaman. Now, of course, at one point you had to pay Santa. And how would you pay Santa? Well, usually these shamans, it was a culture that did not have money or something like that. So you would pay in goods that you produced in, for example, in meat or things like that. And of course, Santa would not necessarily be around when you could deliver the goods. So what did you do, of course? Well, you knew where Santa was stopping because Santa would stop at the trees under which the mushrooms grew. So you knew where Santa stopped. And therefore, you left the payment, the goodies for Santa, you left them at the tree. But of course, you had to prevent foxes and wolves eating that stuff. So what did you do? You put them up on the tree so that the foxes couldn't get them. And here you've got your relationship with Christmas. You've got the Christmas tree. And the Christmas tree, you can perceive that as the payment for Santa when he delivered the drugs. But of course, Christmas is not just all about drugs. Or is it? Actually, there are lots of things that we associate with Christmas. Lots of nice things, aromatic things, tasty things, cinnamon, cloves, allspice, nutmeg, ginger, all these things. And most of these things actually contain ingredients that have pharmacological properties that do something to you. And of course, yeah, you can get high on nutmeg. Cloves, for example, has a compound which is called eugenol, which is a very interesting anesthetic. So you give this eugenol extracts or cloves extracts to little children who are just getting their first teeth. It's a very painful process. You can't give them any anesthetics or paracetamol or something like that, but you can give them this cloves extract, which has strong anesthetic function. And of course, one of a very powerful drug for a lot of people over the Christmas period is ethanol. So why do we get a hangover when we have ethanol? What's the mechanism of a hangover? Headache and dehydration and things like that. Well, the answer is not that easy to see. What's happening is you've got ethanol here, and then you've got an enzyme which is called the acetal dehydrogenase, which oxidizes this carbon here, so it turns it into an aldehyde. Oh, sorry, no, I made a mistake. This is the alcohol dehydrogenase. Alcohol dehydrogenase. It oxidizes the alcohol to the acetaldehyde, and then you've got another enzyme, the acetal dehydrogenase, which then converts it into the acetic acid. But the thing that is the really bad thing is this acetaldehyde here. Acetaldehyde. Because this is the thing that blocks the water channels in the cells. And you can no longer retain the water when you have high concentrations of acetaldehyde. Now, usually we have this enzyme here that detoxifies the acetaldehyde and converts it into the acetic acid. But if you have too much of the ethanol, then you will find you can't detoxify it, and you get an accumulation of the acetaldehyde, which then leads to dehydration. And it makes you feel really rough the next day. So, drink, enjoy your drink, but in moderation. But not all these things are really horrible stuff, like this acetaldehyde. There are other drugs that we can legally take. For example, this drug here, anandamide. Have you heard of anandamide? Has anyone heard of anandamide? No. Have you ever taken anandamide?
Yeah, I took that corner slop.
Yeah. When? In the corner shop? No. Yeah. Yes. Probably you have taken it in the corner shop. No. Anandamide. Actually, the word comes from ananda. Does anyone know what ananda means? What does it mean? Don't move. No. Yes, it means bliss. It's the Sanskrit word for bliss. And this compound here actually is found in dark chocolate. Anandamide is found in dark chocolate, and it makes you happy. Why does it make you happy? Why does it give you bliss? Look at the structure of anandamide and THC, tetrahydrocannabinol. And you see how similar these structures are. And since, I think, 10 years or so, we know actually that anandamide binds to the same receptors in the brain as, for example, cannabis, the component of cannabis, THC. And I think that's quite amazing, because you can get almost the same effect from chocolate as you would get from smoking a joint. Problem is that with anandamide, it is in very small concentrations, so you have to eat a lot of chocolate. And there's another problem with this compound. Absolutely, this is why people can get addicted to chocolate. Although it can have negative effects, because, as I said, there are lots of other components in chocolate, which are not necessarily good for weight loss. So there's a lot of calories in chocolate. Although, did you know that ice cream actually does not have any calories? Eating ice cream is absolutely fine. Ice cream does not have calories. Did you know that? It's true. Ice cream doesn't have calories. If you think about it, the word calorie comes from the word calorus. What does calorus mean? Heat, exactly. It comes from the Latin word for heat. But ice cream is cold. So therefore, ice cream cannot have calories. Very simple. So therefore, it's absolutely legit to have ice cream for breakfast. No, I didn't lie to you. The other problem with anandamite is that it belongs to the class of, it's a component of the arachidonic acids. And this belongs to the prostaglandins, which are compounds that can cause inflammation and basically spots. So if you eat too much of chocolate, you might end up with a state of bliss and happiness, but there's also a good chance that you end up with lots of spots. So be careful with your consumption of anandamide. But as I said, it looks pretty much like THC and it binds to the same receptors. Now, talking about food, talking about eating, how do you get this delicious roast turkey or this gorgeous nut roast? How do you get them with this beautiful color, with this delicious smell, with this wonderful taste? How do you produce this golden color? Yes, I bet this has been photoshopped, but there is also a trick to it. And of course, we are biochemists, and I tell you what this trick is. How do you make this turkey so delicious, or the nut roast with this golden crust? Absolutely beautiful. What you need to do for that is actually you need to do what is called the Maillard reaction. It's named after a French chemist who discovered that. And it's not necessarily honey, but you are going in the right direction. The Maillard reaction is also known as a Browning reaction. And what happens is if you have an reducing sugar, COH, CH, and so on and so forth. So this is a reducing sugar, and you had the practical about the honey with reducing sugar. So you know that this is the reducing group here. And you combine it with CH. So what's that I've just drawn? What is this structure here? What is the structure that I just drew? So here we've got a sugar. Well, it's the R group, yeah, but what is the whole thing? Again, it's an amino acid. We have an amino acid. And if you combine that, these two compounds, you actually get what is originally called a Schiff base. Let's see if I can draw that. And we've got here this CH, R, CO, OH. You get this compound here, which is an imine, because it has a double bond here between the C and N. And you then can rearrange this with in another reaction, which is called the Amadori reaction. And in this Amadori reaction, you convert this compound. You obviously remove water from that. And in the Amadori reaction, you change this product into something like that. HHN CHCOO minus. Here we still have the R group. Here we've got an H. And you have the oxidized carbon in this second position. So this is an alpha ketoamine. And these things, these compounds, can then react to a lot more substances. But these alpha ketoamines give the reaction a really nice smell and nice flavor. But you have to exclude water from it. You have to have sugars and amino acids. And you have to have a temperature around 120 to 150 degrees centigrade. This then gives this Maillard reaction and the Amadori reaction that produces this light brownish color and also a lot of flavors and a really nice taste. How do you do that? Well, here is the trick. So if you are in charge of your turkey or a nut roast or whatever, what you want to do is you want to cook it, and then pretty much towards the end. So for a turkey, I usually do it an hour before the turkey is done. I make a mixture of something that contains amino acids. Something that contains amino acids. What contains lots of amino acids and that you easily have access to? Easy amino acids. Protein powder, yeah, that's a good idea. That would be a good idea. Or you just can use these OXO cubes. Simple OXO cubes. Or if you don't have them, you can even use Marmite, if you like. You mix Marmite or OXO cubes. And you can even use vegetarian OXO cubes, these vegetable OXO cubes. You mix them with a little bit of oil, olive oil, because, as I said, you have to avoid water. If you have water in it, then the reaction will go all the way back and you lose the whole thing. You don't get this browning and the good flavors. So use oil, amino acids, add a little bit of sugar. So you've got all the ingredients sitting there already. Or even better, you can use honey. That gives it a nice flavor. And here comes the trick. This reaction, especially the Amadori reaction, is catalyzed by OH-, by base. You have a base catalyzed reaction. So you need something that you can add here to this mixture that makes the whole thing slightly basic, not too basic. So what could you do for that? What could you use that is slightly basic? Yeah, but then your turkey tastes of mint, probably. Something else that is basic. You just add a little bit of baking powder. Because baking powder is, don't use bleach on your turkey. So with these compounds together, mixed together, put them on your turkey or the nut roast, put them back in the oven, and you get an absolutely gorgeous glaze that then looks like this turkey or this nut roast. But don't leave it in too long because you burn the turkey. No, you don't use bleach on a turkey. I'm terribly sorry. And don't cremate the turkey. You just should cook it and not cremate it. So, what did we learn today? Rudolph is not a male. Santa is probably a drug dealer and definitely a crackhead. Alcohol has problems. Lots of spices have psychoactive substances, and also mushrooms have these psychoactive substances that can make you do very weird things. So don't do drugs, kids. Dark chocolate also contains drugs, but I consider that as something that's quite pleasant, and we don't need to worry too much about it. Although too much chocolate makes you, a little bit more on the larger side. And it also contains other compounds that are probably not so good for you. And the magic recipe for the perfect turkey is a combination, is a mixture of OXO cube or Marmite, a little bit of olive oil, honey, and a dash of baking powder. Just glaze the turkey with that, and you will have an absolutely, this will be the hit of the festive season. Speaking of which, my time is up. So I can only wish you all a very peaceful, happy, and let's not forget, safe, Merry Christmas. I wish you have a wonderful break. You truly deserve it. And I'm very much looking forward to seeing you next year, next term, in actually exactly a month's time. Hopefully, everybody is safe and we can enjoy life. Merry Christmas and have fun. Enjoy. Take care. See you next year.
Bye.